Hello, everyone. My name is Phil Galata. I work at Purple Innovation as the Director of Maintenance. Today, I'm going to walk you through how we've implemented L2L and how we utilize the system. This is a higher level summary. There will be a 10-minute Q&A at the end, so please feel free to jot down any questions you may have so we can answer them at the end of the presentation. What is Purple? Well, Purple Innovation is a company that originated in Alpine, Utah. We currently have a facility in Grantsville as well. Purple is a comfort technology company. We have a proprietary hyperelastic polymer or grid that we use in a majority of our products. We're mostly known for mattresses, but we also make pillows and seat cushions, blankets and sheets, bedding accessories. All of these products have contributed to Purple's growth. In Q4 of 2016, we reported $24.6 million in revenue, and in Q4 of 2019, we reported $428 million in revenue. This is a revenue increase of 1,639%. You can tell from this 3-year growth rate that we were growing quickly and we didn't have a maintenance system to support the business. So we needed to make a decision and we needed to do something quickly. To get started, I've added some data here to give us some perspective as we walk through these slides. And you've seen what we've achieved over the last 2 years. These metrics may help give you some perspective. So our asset count alone in the 2 years has grown 596%. So we've added a number of new machines. Our mechanic employee count has increased 128%. Dispatch completion count. So we are completing up to 3,029 dispatches every month. So this has increased 536% in 2 years. So we're closing many dispatches. Our PM completion count started at 47, and we're now completing about 1,968 PMs each month. This is a 4,000% increase. We're completing PMs on a regular basis, but as you'll see later on in the presentation, there's a few of our machines that we complete a number of PMs on each day. We'll get into that a little bit more later. So our PM completion percentage itself started out around 46%, and it's currently about 86% on-time completion. That's largely due to our maintenance planner and our supervisors and our maintenance team executing a well-organized plan. Our spares count has increased 2,000%. When we started, most of our parts were on pallets. There was very few of them. So that one, although it's taken a lot of effort to get where we are, there was exponential growth right from the start, just simply because we didn't have much. As I discuss Purple's L2L journey, I hope there are a few takeaways you can use and implement in your current system and/or when you go to implement Leading to Lean. Prior to me starting at Purple at my previous employer, I had inherited and developed a computer maintenance management system, a basic CMMS. I had created all the asset tags, all the preventative maintenance schedules, all of the machine bill of materials. So I had some experience with CMMS, but it wasn't too long after development that we outgrew the system and we looked for a more powerful tool. This is what led me to implementing and developing Leading to Lean at my previous employer. And once I arrived at Purple, I had already known the difference between basic CMMS and Leading to Lean. So I knew what I wanted for Purple. It was a matter of getting upper management's buy-in to allow me to pursue Leading to Lean. At this point, they had already determined which CMMS they were going to go with. So I had to persuade them to ditch that effort and proceed with Leading to Lean. I've broken the presentation up into 3 phases: implementation, system development, and future state. Implementation and basic setup. You're going to want to start with a vision and a plan. This way you can lay out what you want your hierarchy to look like, how you want your reporting structure to function. These are important to understand upon implementation to ensure that the system is set up properly. L2L can help you with that, but it is very helpful if you thoroughly understand how that system functions as far as the hierarchy and the reporting structure. Obviously, you'll have to label all your assets. You should pick a scheme that supports your company growth so you don't paint yourself into a corner with asset labeling. You complete the initial load with all of the existing PMs and bill of materials, technical documents, etc. You're going to want to train your team. L2L can help with that, but you will need someone who understands the system very well so that once Leading2Lean leaves and has completed their training, you can continue down that path of strong understanding with your technical resources. And then you're going to want to ensure you've baselined all of your data if you have any. Implementation highlights. I would start with the success of the vision and plan that we had laid out prior to implementation, the buy-in we gained from the maintenance mechanics and the production staff and all the supporting departments. This buy-in helped the system grow and develop at a rate that none of us expected. We displayed and communicated the baseline data, let everybody know what was status quo, where we're at, and then we communicated our goals and our metrics. Where did we want to be? Before we get into system development, I really want to stress evolution and change. The L2L system at Purple is not exactly what it was when we first implemented. It has evolved. New processes have been added. So I can only stress the encouragement of change and utilizing L2L to solve problems on the shop floor. So always be refining and improving processes using the system. Make changes on the go via a smartphone or an iPad. Use the data collected to prioritize your workload and focus the team. Celebrate all wins, big or small. Use the baseline data to drive improvements. And then last but not least is definitely data collection accuracy. So we really like to press accuracy over anything. If you have bad data, you just can't use it. Our first stop in system development is PM checklists. The checklist that you see pictured is an actual checklist that we use on one of our lines. This PM checklist was initiated from day one. Before we handed the system or the line over to production, all of these photos and descriptions were in L2L and launched for the first cycle of PMs. The photos are with brand new equipment, obviously, so the technician can clearly see what it should look like versus what it could look like as time goes. These PMs were completed by the maintenance planner, the subject matter expert, and the maintenance supervisor over that area. Over time, as we learn more about this line, we will modify the checklist based on the system needs. We run a 24/7 operation, so all of our PMs need to be planned and the equipment needs to be taken out of service before we can execute. So production is very easy to work with because they've seen the improvements that our PMs have made to their capacity and their machine uptime. We currently have 109 active PM schedules in the system, many of which have been added based on data collected in the system. Moving on to the MRO crib in system development, the two photos in the slide show current state on the top and what we initially started with on the bottom. The maintenance shop took up much of this space in the beginning. It's recently been moved in order to expand the MRO crib. We've hired crib clerks to manage the counter and manage the inventory. All of our parts in L2L have photos. We use a parts queue, which we'll talk about a little bit more later. Our MRO clerks kit parts for us for projects and PMs. We currently have 1,195 active part numbers. 476 of them are in stock. We use an economic order quantity for our reorder methodology. Dallin Johnson, our maintenance planner, has done much of this research and has developed our min-max levels based on this and a few other methodologies, but this is the main one we use for reordering now. Our annual turnover is about 60%. This slide shows underneath the mezzanine. The photo on the top left is current state. The photo on the bottom left is what we originally started with. That space we quickly outgrew. This mezzanine and upgraded shelving increased our storage by 5 times. The MRO clerks have a scooter to allow them to pick parts, deliver them to the line, pick them up from receiving. It gives them a way to navigate the shop floor in a quicker manner. The middle photo shows the MRO crib office and the parts queue. So this queue in L2L allows mechanics on the line to consume a part, and it pings the MRO crib attendant to go and pick that part out of inventory and have it ready for them at the counter when they arrive, and or if the mechanic radios them to deliver it to the line if it's urgent. Now, much of these MRO crib improvements, you could argue, don't have much to do with L2L. In reality, they have a lot to do with L2L. We carry very expensive spares, and we're asking for a lot of money from Purple to support us in our MRO crib initiatives. And without a tool for us to manage this efficiently and accurately, we wouldn't be able to justify it. We wouldn't be able to monitor and track all of these components that are needed to keep the equipment in ideal operating state and condition. Next, in system development, we have the document center. This document center is vital for the technicians' technical information, schematics during troubleshooting, whatnot. My advice would be for categories to just simply get started. I believe we started with mainly preventative maintenance, maintenance manuals, just a couple of different categories. And the system's now developed into, I don't know, a dozen or 18 or so categories. This is after production and other departments have started to utilize it. The approval process via the categories is vital because if you can imagine, as the system grows, you're going to want others to be able to submit their ideas for improving a document. And many people at Purple have this ability. And once they make their suggestion or their request, it goes through an approval process. So they're not just publishing everything that comes through. There is an approval process for someone to review and audit prior to publishing that change. But it does allow the system to grow and develop. Standard naming conventions for technical documents is another good point that I like to stress. We have a standard naming convention mainly for technical documents. For maintenance manuals, for example, we start with the manufacturer, and then we have the asset description, then we add the model number, and then the file purpose, i.e. maintenance manual or operations manual. This allows us to have a standard naming convention, and it keeps everything organized, and you know how to search for the file you're looking for simply because the naming convention is standardized. For PM checklist recommendations, I use the same one that L2L suggested years ago. So it's frequency, it's a weekly or a monthly, the asset description, and then the file purpose, i.e. checklist. Pretty standard and easy, but that's an L2L, or a shout out for Eric. He's the one who suggested it. We currently have 472 active documents in the system, and almost all of our technical documents are electronic. Our mechanics have laptops on their toolboxes that they roll around with them during repairs. They do print out a page or two during troubleshooting. This way they can make some notes and jot down any other information they may need. But we don't have any large file cabinets full of paper documents. We convert anything we get from the manufacturers into electronic copy. Next in system development is production. Now, although Purple does utilize the production module, much of what I'll discuss today is a way that production utilizes the dispatch module, is the Kaizen event module, which is pictured on the slide. They use this for 5S and other tasks and projects that they can assign additional dispatches to keep track of multiple tasks at one time. This allows them to track progress when everything's completed as a whole and not just on an individual task basis. In addition to projects, they have what they call a production event dispatch. This is where they capture quality issues or any type of deficiency on the shop floor. So right now, when we have a quality deficiency, they're able to launch a dispatch which attaches what we call a yellow card checklist, where we require the information to be logged and attached to that specific mattress or quality defect. This allows you to pull the mattress off the line so we can continue to produce while a quality inspector comes to inspect that mattress and identify the information logged in the checklist. This obviously gives us visibility to all of the quality issues and allows us to properly trend and understand if we're improving and or needed to make process changes and whatnot. In addition to those types of dispatches, we have operators who submit operator fixes for any type of stoppage on the line, whether it's a material change or a material shortage, a small, a jam or small operator fix. They're logging almost all stoppages to ensure that we understand the overall availability of that piece of machinery. We also have a production admin. His name is Trevor Thornton. Trevor's really added horsepower to improving the system from production standpoint. Much of the maintenance side of the system is managed and developed by maintenance and supervisors and maintenance manager and the maintenance planner. But production, once they started using the production module, really needed an admin to help manage the influx of recommended changes and improvements. So he's been a great help to the system development. Next, in system development, I've got a machine example for improvement. So we have a machine we call Max Machine. It produces our hyperelastic polymer or grid. Now, these machines were designed and built in-house. When I started at Purple, we only had 2 of them in service. Now we have many more of these machines, but our maintenance system has changed drastically. When I first started at Purple, we had a mechanic that would maintain this equipment full time. They wouldn't leave this machine side with the exception of breaks and lunches. Now we're on a standard PM frequency. So for example, from the time we've implemented L2L to today, we've updated some of these schedules on this machine 29 different times. So everything we learn day to day, we're making changes, and we've got to a place where the machine is reliable compared to what it was. We execute a bi-hourly inspection PM on this machine. Bi-hours meaning every 2 hours. Now, it seems like it's extremely excessive, but if we don't complete these inspections and identify issues beforehand, they turn into very large issues very quickly. So we find it very important to spend 15, 20 minutes evaluating and inspecting the machine every 2 hours, which prevents very costly downtime and expensive repairs. In the 2 years that we've logged data on this machine, we've been able to decrease downtime on the original Max machine in Grantsville by 54%. We largely contribute that to the information that the system has been able to provide us for us to re-engineer and redesign new solutions. For system development highlights, I'd like to start with dispatch types. The first one being the parts request dispatch type. Mechanics use this anytime a part is needed and it's not already on the bill of materials. They request it via this dispatch type, and our MRO clerks see this, they log it as part of that machine's BOM, then they order it. So it's like a one and done deal. You're continually building those BOMs. Second is the dispatch data correction dispatch type. So this is a shout out for Curtis Bird at L2L. This dispatch data correction is used anytime we're auditing dispatches and we notice there's a discrepancy. We create a follow-up dispatch to that original dispatch for the mechanic to go back and review and correct. This helps training reiterate why we use certain reason codes or action codes, or when we have missing information. It allows us to then also track their performance as for correctly logging the information in the system. Third is running preventative maintenance PM dispatch type. It's essentially an inspection that is completed while the machine is running in operation. Now, this may need some engineering work on the equipment side to ensure that it's done safely, but we do a number of RPMs throughout the day. This is in lieu of a TPM program where operators will complete OPMs. Next is the parts matrix. Dallin Johnson, who was our maintenance planner and originally started in MRO, he developed a matrix based on industry standards, and he can throw in a part and some data, and it'll kick out what our min max should be based on a number of factors: lead time, cost, usage, things like that. So that really helped jumpstart the MRO crib spares. The MRO crib expansion definitely helped. We wouldn't be able to hold as much inventory as we do now, and it wouldn't be as organized and as efficient. We've integrated a number of our machines into L2L. So these PLCs on our machines, when they fault out or there is an error, it'll automatically generate a dispatch in L2L, what we call a PLC generated code red or a PLC generated code yellow. Last would be making goals transparent to all and ensuring that you have good communication as the system develops, and there's a reason for why things are done the way they are, and a healthy relationship for people to challenge that system for improvement. For future state initiatives, we'd like to expand the PLC integration with L2L. This way we have more machines automatically generating dispatches when there are issues. Optimize our PM program. We've already kicked this program off. We've just started, so we'd really like to start reviewing the data and relating it back to occurrences and issues, and start changing frequencies and refining our PM program in an effort to get rid of high frequency PMs like the bi-hourly. We're going to better utilize the skills module, especially for employee training and onboarding processes. Improve the integration with production and the quality department. Those are two very important pieces of our business, and maintenance and quality and production can be integrated better, in my opinion. We'll also start a TPM program so that operators can start to complete OPMs and inspections that the mechanics are doing at the moment that take up valuable resource time. As a conclusion, prior to implementation, be sure you formulate a solid plan to achieve your objectives that you set forward. As you utilize the system, ensure it's constantly developing, and regularly ask yourself, how can I use L2L to solve this problem? Future state, always be planning ahead. Things are always evolving, and things can almost always be improved. As a close, at Purple, I work with a number of employees who have industry knowledge and have worked with many other systems, and they have nothing but good things to say about Leading to Lean. But none of this would be possible without all of the effort that the Purple employees have put into the system to develop it to what it is today. Thank you, Purple employees, and thank you, Leading to Lean.